What's up, team? Quick question before we start. Do you actually know Amazon Web Services global infrastructure, regions, availability zones, and edge locations? By the end of this video, you will. Let's dive in. A single word in your architecture doc can make your company violate GDPR before you write a single line of code. That word is region, and picking the wrong one is a legal liability, not just a latency problem. In episode 2, we said Amazon Web Services lets you go global in minutes. Today, we unpack what that globe actually is. By the end of this video, you'll know how regions, availability zones, and edge locations fit together, the 3 region extensions, and which services are truly global instead of regional. Two terms to anchor the start. A region is a geographically isolated physical location containing a cluster of data centers. An availability zone, or AZ, is one or more discrete data centers inside a region, each with redundant power and networking. We'll pick up edge locations, local zones, and outposts as we reach them. Picture this: a code gorillas team sits down to architect a workload for a European fintech client, and the client has GDPR obligations. Here's what's interesting. Before anyone opens a whiteboard and draws EC2, RDS, or a Lambda function, the very first decision they make is a region. That single choice locks in which laws apply to the data, how fast users see responses, which Amazon Web Services are even available, and how much they pay per hour. Get the region wrong, and you've violated data sovereignty before you've written a single line of code. So how does one word in an architecture doc become a legal liability? That's what the next half hour is about. Here's the whole infrastructure on one slide. On the left, we have a region. Think London. Inside that region are at least 3 availability zones, each one a separate data center cluster with its own power and its own networking, but connected to the others by private, low-latency fiber. That's the building block of high availability. And then on the right, completely separate from any single region, you have hundreds of edge locations sprinkled around the world, sitting close to where your users actually are. 3 tiers: region, AZ, edge location, and each one does a fundamentally different job. Here's the mental model I want you to carry through this whole video. Picture Amazon Web Services as a global pizza chain. A region is a city: London, Tokyo, Frankfurt. An availability zone is a separately owned kitchen inside that city, so if one kitchen burns down, the others keep cooking. And an edge location is a delivery bike depot on every street corner. It doesn't cook anything, it just holds copies of the popular pizzas so they get to your door fast. 3 tiers, 3 completely different jobs. Let's nail down the region first. A region is a geographically isolated physical location with a cluster of data centers in it. You'll see regions named with codes like US East 1, which is Northern Virginia, or EU West 2, which is London. Every region is fully independent from every other region, and this is the part most beginners get wrong. There is no automatic data replication between regions, ever. If you want your data in 2 regions, you build that yourself, deliberately, with an explicit feature. Here's what that isolation actually means in practice. Imagine an RDS outage in Tokyo at 3 in the morning. Your Frankfurt workload, serving European customers, doesn't even notice. No cascading failure, no shared blast radius, no pager going off in Berlin because of something that happened in Japan. That's the design, and it's why one region's bad day cannot become every region's bad day. Picture each region as its own island. Nothing swims between islands unless you build the boat. Your S3 bucket in Ireland is not magically backed up to Frankfurt. Your RDS database in Tokyo does not automatically appear in Sydney. Cross-region replication is a feature you turn on, a pipeline you build, or a managed service you opt into. The default is total isolation. So how do you pick one? 4 criteria, in this order. First, compliance, data sovereignty and regulatory residency. If GDPR or BFIN or HIPAA dictates where the data has to live, that's the conversation that ends before any other one starts. Second, latency to your end users, closer region, faster responses. Third, service availability, because not every Amazon Web Services service launches in every region on day one. And fourth, price per hour. Costs vary significantly between regions. São Paulo in particular tends to be among the most expensive, driven by local taxes and infrastructure costs. Compliance picks the region, the other three break ties. Back to our fintech. GDPR already narrowed the choice to the EU, so the real conversation is between two regions. Frankfurt, EU Central 1, tends to win for German BaFin regulated workloads, where data sovereignty culture is strict and the regulator sits in Bonn. Ireland, EU West 1, tends to win when the client wants pan-European traffic to stay internal to the EU as a whole, with broader service availability and often lower pricing. Same compliance bucket, different tiebreaker. Now zoom inside a region. An availability zone is one or more discrete data centers inside that region. Each AZ has its own redundant power, its own cooling, its own networking, and its own physical security. The availability zones in a region are physically separated from each other, but they're linked together by private, high bandwidth, low latency fiber. And here's the rule worth committing to memory. Amazon Web Services designs each region with a minimum of 3 availability zones. A small number of older regions may show only 2 AZs to some accounts due to capacity constraints, but the exam treats 3 as the standard minimum. This is what a multi-AZ production deployment looks like. User traffic hits a load balancer at the top. The load balancer fans the traffic out to compute running in AZA, AZB, and AZC, 3 separate data center clusters in the same region. Underneath, your database runs as a primary in one AZ, synchronously replicating to a standby in another. If AZA loses power tomorrow at 3 in the morning, the load balancer simply stops sending traffic there. Your database fails over to the standby, and your users never even notice. Here's the rule I want you to memorize. Single AZ deployments are for development and test only. Every production workload on Amazon Web Services starts multi-AZ. The cost difference is small, usually 1 extra compute instance and a standby database. The resilience difference is enormous, because one data center fire stops being an outage and becomes a non-event. If you only take one architectural pattern from this whole video, take this one. When 2 teams share subnets across accounts using the AZ name, say, US East 1A, they often assume they're in the same physical building. They're not. The AZ name was historically mapped randomly per account, so your US East 1A and my US East 1A can point to completely different data centers. Traffic that looks like it's staying inside one AZ silently crosses AZs, and you get hit with cross-AZ data transfer charges nobody budgeted for. The fix is the AZ ID, something like use 1 as 1. It's consistent across every account and always points to the same physical AZ. When you're coordinating resources across accounts, always use the AZ ID. One quick note: in November 2025, Amazon Web Services began using consistent name mapping for brand new accounts, but any older account still has the random mapping, so the AZ ID rule still applies. This distinction also comes up in scenario questions about cross-account networking. Straight from the Amazon Web Services documentation, the US East 1A availability zone for your account might not be the same physical location as it is in another account. The string is identical. The physical data center is different. When you share resources across accounts, use the AZ ID, never the AZ name. Now let me show you when multi-AZ is not enough. Imagine a scenario where a bug inside a regional control plane, the layer that sits above all the availability zones and manages things like internal DNS, wipes out critical records. Because so many Amazon Web Services depend on that shared control plane, the damage cascades. Identity services, automation services, compute control planes all start failing. Notice what happens to the multi-AZ customers in that scenario. All three availability zones in the region are affected at the same time, because the failure isn't inside any one data center, it's in the regional layer sitting above them. Multi-AZ doesn't save you, only multi-region customers can fail over to a completely separate region. So the rule you want in your head is layered. Multi-AZ survives a data center failure. Multi-region survives a region failure. Tier 1 services, the ones whose downtime makes the news, need both. When a scenario asks for high availability within one region, the answer is multi-AZ. When it asks for the highest possible availability or disaster recovery across regions, the answer is multi-region. An edge location is a small Amazon Web Services facility placed close to where your users actually are. There are over 750 standard points of presence around the world, far more numerous than regions. Their job is to cache content and terminate connections close to the user. 4 services use edge locations: CloudFront for content delivery, Route 53 for DNS, Global Accelerator for traffic routing, and Amazon Web Services WAF when it's protecting a CloudFront distribution. One important caveat on that last one: WAF is only an edge service when paired with CloudFront. When WAF protects an ALB or API gateway, it's a regional service, not an edge one. And here's the line that catches people. You cannot launch an EC2 instance in an edge location. You cannot store an S3 bucket there. Edge locations are for caching and connection termination, not for general compute or storage. Let's put the two side by side. A region is where your compute, storage, and databases actually run. There are 39 regions worldwide as of late 2025, and your origin workload, the real thing, lives in one of them. The downside is that users on the other side of the planet experience high latency talking to that region directly. An edge location is the opposite. It only caches and terminates connections. There are over 750 standard points of presence, and they sit between your users and your region. The result is that a user in Singapore talking to an origin in Ireland feels like they're talking to something local. Here's what that looks like in practice. A Disney Plus Master 4K video file lives in S3 in a single region. Now a viewer in Singapore presses play. They're not streaming from that region across thousands of kilometers. They're streaming from an edge location in Singapore. The very first request does pull from the origin region, but it warms the cache. Every subsequent viewer in Singapore is served locally. That's why the video starts almost instantly, even though the master file is on the other side of the world. There are also 3 extensions of a region that show up in scenario questions. A local zone is an Amazon Web Services operated extension placed in a major metro area like Los Angeles or Las Vegas, offering a subset of compute, storage, and database for single-digit millisecond latency to users in that city. Good fits are real-time video editing, gaming, and machine learning inference. Wavelength embeds Amazon Web Services inside a telecom carrier's 5G network, so mobile traffic never leaves the carrier network. That's for connected vehicles, augmented and virtual reality, and industrial Internet of Things. Outposts is a rack of Amazon Web Services managed hardware that Amazon Web Services ships to your own data center, for workloads with on-premises residency requirements or sub-10 millisecond latency to local equipment, like cameras on a factory floor. Don't try to memorize the internals of these 3, just recognize the use case. Local zone means metro low latency. Wavelength means 5G mobile edge. Outposts means Amazon Web Services hardware on your premises. If a scenario mentions a city without a nearby region, think local zone. If it mentions 5G or carrier networks, think wavelength. If it says on premises or in their own data center, think outposts. The last big distinction is global versus regional services. Think of it like a passport versus a driver's license. Global services are like a passport, one document, recognized everywhere. The 5 canonical global services are IAM, Route 53, CloudFront, Amazon Web Services WAF when it's used with CloudFront, and Amazon Web Services organizations. You create those once and they work across every region. Regional services are like a driver's license, issued by one state and valid mostly there. EC2, Lambda, ECS, S3 buckets, RDS, DynamoDB, VPCs and subnets. Almost everything else is regional. One subtle note on S3. The bucket name lives in a global namespace, so it has to be unique across every Amazon Web Services account, but the data itself is stored in the specific region you pick at creation. If you operate in 3 regions, you maintain 3 copies. Now here's the part that surprises a lot of engineers. Most so-called global services actually run their control plane in one specific region. Route 53, CloudFront, WAF for CloudFront, and Shield Advanced all have control planes that's stored in US East 1, Northern Virginia. The Amazon Web Services Certificate Manager certificate you attach to CloudFront has to be requested in US East 1 too, no matter where your origin lives. The implication is uncomfortable but important. When a regional control plane in Northern Virginia triggers a cascading DNS resolution failure, that local incident becomes a global incident, and that's exactly what we saw in the October 2025 outage. Here's the decision rule that ties it all together. When you see a scenario about global users and cacheable content, you pick CloudFront, which runs at the edge locations. The keyword is global delivery. When you see a scenario about load balancing your application across AZs within one region, you pick an application load balancer, which is a regional service. The keyword is high availability in a region. And when the scenario calls for single-digit millisecond latency to a specific city that doesn't have its own region nearby, you pick a local zone. The keyword is metro low latency. 3 patterns, 3 keywords, match them and the right answer becomes obvious. Before you answer any scenario question on this material, run this 3-line checklist. Does the question mention compliance, data residency, or country-level latency? That's a region answer. Does it talk about surviving a single data center failure inside the same geography? That's an AZ answer. Is it about caching static content close to users, or terminating connections near them? Edge location. 3 triggers, 3 answers. Let's lock in the takeaways. Region choice is the first architectural decision, ordered by compliance, latency, service availability, then price. Every region has at least 3 availability zones, and multi-AZ is the default for any production workload. Multi-AZ survives a data center failure. Multi-region survives a region failure. Edge locations serve CloudFront, Route 53, Global Accelerator, and WAF. They do not run compute. And the 5 canonical global services are IAM, Route 53, CloudFront, WAF, and organizations. Almost everything else is regional. Back to our Code Gorillas team and their fintech client. They now know exactly why EU Central 1 is in the architecture doc before a single service is chosen. That one word is doing a lot of work. Question 1. A company needs to deliver streaming video to viewers in over 80 countries with the lowest possible startup latency. The master files are stored in S3 in a single region. Which Amazon Web Services infrastructure component is most directly responsible for the low latency delivery? Is it A, additional Amazon Web Services regions in each country, B, multiple availability zones in the origin region, C, edge locations through Amazon CloudFront, or D, Amazon Web Services local zones in each major city? Pause here if you want more time. The right call here is C. Edge locations, accessed through CloudFront, cache the video close to viewers worldwide. Adding regions is expensive and slow. Adding AZs only helps inside one region, and local zones target a single metro at a time, not 80 countries. Question 2. An engineer is designing a production web application that must remain available if a single data center fails. The team wants the simplest architecture that meets the requirement while staying within one region. What should they do? A. Deploy all resources in a single availability zone with automated backups. B. Deploy across at least 2 availability zones behind a load balancer. C. Deploy across 2 Amazon Web Services regions with cross-region replication. Or D. Deploy to an Amazon Web Services outposts rack inside the corporate data center. Think about which constraint matters most here. It has to be B, and here's why. The requirement is to survive a single data center failure inside one region. That is exactly what multi-AZ behind a load balancer solves. Single AZ fails the requirement. Multi-region works but is more than needed, and Outposts is on-premises hardware, which doesn't address AZ fault tolerance at all. Question 3. A European fintech is subject to GDPR and must keep customer data resident in the European Union. Which selection criterion drives the region choice for this workload? A. Price per EC2 instance hour. B. Compliance and data sovereignty. C. Availability of the newest Bedrock models. Or D. The number of edge locations near customers. Run the decision rule from earlier before you answer. The answer is B. Compliance and data sovereignty always come first in region selection. Once GDPR has narrowed the field to EU regions, then price, latency, and service availability can break ties between Frankfurt and Ireland, but compliance picked the geography in the first place. Question 4. Which of the following Amazon Web Services is global rather than regional, meaning resources are created once and used across all regions? A. Amazon EC2. B. Amazon RDS. C. Amazon Web Services Identity and Access Management, or IAM. Or D. Amazon VPC. Lock in your answer before I give it away. If you said C, well done. IAM is global. Users, groups, roles, and policies span every region in your account. EC2 instances, RDS databases, and VPCs are all regional and have to be configured separately in each region you operate in. Last one. A company needs single-digit millisecond latency to end users in a specific major metro area for a real-time multiplayer gaming workload, but the users are connecting over standard internet, not a 5G carrier network. Which Amazon Web Services region extension fits best? A. Amazon Web Services Outposts. B. Amazon Web Services Wavelength. C. Amazon Web Services Local Zones. Or D. CloudFront Edge Locations. Lock in your answer before I give it away. The right call here is C. Local Zones. Local zones place compute and storage inside a major metro for single-digit millisecond latency over normal internet. Wavelength is the answer when the requirement says 5G or carrier network. Outposts is for hardware in your own data center, and edge locations cache content. They do not run your game servers. That wraps up Amazon Web Services global infrastructure, regions, availability zones, and edge locations. The Amazon Web Services Certified Cloud Practitioner Exam Mastery has more videos coming on the trickier topics. Subscribe so the algorithm tells you when. Thanks for watching.